Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today's lesson will be in 11.4, and that's called Solving Rational Equations. So now we're doing equations with fractions. All right, so from last lesson was pretty complicated. From last lesson, I think this one's a little bit better for you. Maybe it won't be quite as complex, but we're using some of the same principles that we learned in the last lesson. So hopefully you remember some of those, especially how to find the LCD, and we're going to use that again in this lesson. So go ahead and jump into your book on page 448, page 448, 11.4. Solving rational equations. Notice that the rational equation is an equation containing one or more proportional expressions. So basically, what's proportional mean? It means fractions, right? So you've got, if you remember this, the means equals the product of the means equals the product of the extremes. Hopefully you remember those words from back when we were doing maybe 8th grade math. So let's go over here real quick and let me show you this, and then we'll kind of go from there. So if I have 1 over 2 equals 4 over 8. This is a proportion, right? It's the same thing. It's just a non-reduced fraction. So in other words, if I multiply this by 4, then I get 4. And if I multiply this by 4, I get 8. So 1 times 4 equals 4, 2 times 4 equals 8. This is proportional. That's what the equal sign means. It means that these two things are equal to each other. Now, one way that you can solve these, like let's say that I had an x right here and I didn't know what that was. Well, one way that you can solve these is you can do the means and the extremes. You basically do those two different things and you multiply them times each other. So 1 times x equals 2 times 4. 1 times or 1x is just x equals 8. So just like we had 8 in that spot a second ago, we can solve it using the means times the extremes, or the product of the means equals the product of the extremes. So again, that was something, this right here is something that you did like in 7th and 8th grade math. Well, we're using the same concept again here, but now again it's just a little bit more complicated because we have fractions involved. So, but the same process. What's the process? We're going to multiply here and we're going to multiply here. When these are simple proportions like this one is, in other words, there's no plus or minus signs. I know you say, well, these are both binomials. I know, but what I'm saying is it's not like a binomial plus a binomial or a trinomial plus a binomial or something like that. When it's fairly basic, you can use this process right here and you will get the right answer. So let's go ahead and put x minus 5 times this. It goes diagonal. So so if I'm using the upper left, then I would use the lower right. So it's the x minus 4. Multiply those together. That's going to equal these other two. So the x plus 4 times the x minus 1. All right, now what we do is we go ahead and we actually FOIL these. So first, outer, inner, last. So we'll do the first, and we'll get, let me change colors so you can see this a little bit better. That's going to give you x squared. X times x is x squared. And then the outers are going to give you a minus 4x. The inners are going to give you minus 5x. And then the last, there we go, is going to give you a positive 20 equals, and then we'll do the same thing here. There's the outers, so we'll do the first, okay, and we'll get x squared again, and then we'll do the outers, and we'll get minus x, minus 1x, and then we'll do the inners, and we'll get plus 4x, and then we'll do the last, so 4 times negative 1 is negative 4. All right, so we just have this big monster, kind of polynomial that we're just going to kind of combine what we can combine, and we'll see what we get for an answer. So again, let me change the color so we can make this make a little bit of sense. So I'm going to first of all take this x squared. Actually, let's just combine what we can combine first. So let's combine this right now, and that's going to give us a x squared minus 9x plus 20 equals x squared, and this is going to give us a plus 3x minus 4. All right, so now what I want to do is I want to go ahead and start moving things to the other side. So I always, we always like to have x equals something, right? So we will move let's first of all start with this x squared. So let's move the x squared. So subtract x squared from both sides, and that's going to cancel. Both of those are going to cancel. And then so that we leave the x on this side, let's move this 3x over here by subtracting 3x from both sides. And that's going to give me a negative 12x. And then I'll take this positive 20 and move it over here. So minus 20 from both sides. And that's going to equal a negative 24. And then I'll divide both sides by negative 12. And I'll come up with x equals, and it's going to be a positive 2. Okay, so that's going to be my answer. X equals positive 2. Again, lots of stuff going on there, but it's all stuff that you know how to do. Just be very careful as you go through that process not to mess up any negative signs. Make sure that you're writing everything all the way down. All right. Now we get to this one that's a little bit different. And so here's what's different about this. Now we have a fraction over on like two fractions. So a fraction plus a fraction. And that's a lot more complicated. And then we don't even have a fraction over here. So what in the world are we going to do with this? Well, what I like to do with this is I like to eliminate the fraction. Like I don't want these fractions. So what I want to find is I want to find the LCD, the least common denominator. And I'm going to make this a fraction too. I'm just going to put 2 over 1, okay? So again, what I like here is I say, what ones do I need? Well, I have an x here and a 4 here and a 1, so I need a 4x. My LCD is going to be 4x. Now what you do is you multiply everything by 4x, or 4x over 1. Okay, so every piece gets this. Okay, all 3 of these pieces you have to multiply by the LCD. Why are you doing this? You're doing this to eliminate the fraction. We don't want the fraction, so let's eliminate the fraction. All right, so what happens here is we get a cancel, cancel. And now we have a 4 times 7 is going to be 28 over 1. We don't need the over 1, so just 28. And then we're going to get plus, and we're going to do the same thing here. This cancels, and up top we just get x over 1, so just x, equals, here we're just going to get 2 times 4 is going to be 8x. All right, now we're in pretty good shape. Again, I kind of like to get the x's over here on this side, but it doesn't really matter. On this one, let's take the x over to this side. So we'll subtract a 1x from both sides minus x. It's going to cancel. We're going to get 28 equals 7x. And then we can divide both sides by 7 in this case. And we're going to come up with x, and I'll switch these right now. So x equals, and then 7 gives us 4, and that would be our final answer right there. Now, there's a way to check these. All right, so what you want to do is take that 4 and go back here into your original equation. Let me show you what that looks like. So we'll come over here. So we'll get 7 over 4, because that was an x there, and then plus 1 over 4 equals 2. That's a 1. All right, so what's 1? 7 plus 1 is 8 over 4 equals 2. 8 over 4, 2 equals 2. Okay, once you divide that out, you get 2. All right, so that checks. So that's one way to check these to make sure that you're getting the right answer. But on that first one that we did, this was a whole lot I guess, more complicated process. So these ones can seem like they're a little bit easier, but then it takes a little bit longer to do them. So if you don't have a fraction on both sides, you can just do the means times the product of the means equals the product of the extremes. Just do this cross multiplication right here, okay? If you do have two fractions on one side of these, then you want to eliminate the fraction, and that's going to make the whole thing simplify out. All right, let's do this one. So now we have the same thing. We'll just make this into a fraction. We'll make this into a fraction. We want to write the LCD over here. So what is the LCD of this? Well, it's x. Okay, so we're going to multiply everything times x, or x over 1. All right, so let's go ahead and multiply these all out. We'll multiply this one, then we'll multiply this one, and then we'll multiply this one, okay? X times x gives me x squared minus, and then we have, this is going to cancel, x and x cancel, and so I just have a 4, or a 4 over 1, so just a 4. And then our equal sign, this is a -3. There's nothing on the denominator here, so we just multiply these two. So -3 times x is -3x. And then this one's a little bit different. So we have the x squared. You might be like, I don't like x squared. I know, but we're stuck with it this time. So what we want to do is we want to turn this into something that we can factor. So let's move the 3x over to this side, and we will get x squared plus 3x minus 4 equals 0. Now that we have this here, we can factor this. So when you don't get an x squared to cancel, like we did in the other one that we just did, we want to try to factor this. So we'll factor it, and we'll say an x and an x, and our negative here means that we'll have a positive and a negative. The fact that this is a positive 3 means that the bigger one will be positive, so we'll use the 1 and the 4. So this is 1 and 4, or 2 and 2. On this one, we'll use the 1 and 4 because it gives us a 3 here. And so we'll put the 4 positive, and we'll put the 1 negative. And that's going to equal 0. So both of those. Now, here's the trick. Both of these equal 0. It's called the zero factor principle. So that one equals 0. And the x minus 1 also equals 0. To find the solutions for these, we would just move the -4 to the other side, or +4, by subtracting 4 from both sides. X equals -4. That would be one answer. And then we would do the same thing with this, and we would get x equals +1. So those would be our two answers there, -4 and 1. All right, same thing on this one. We're going to find our LCD. So our LCD is going to be, remember I said one of each. Notice this one looks like it can be factored a little bit, and it can be. We can pull an x out of this one, and then we get an x minus 2. So that's the factorization of this. It's a common x. There's an x in both of those, so the x comes outside. So this one, notice that there's an x and an x. That's common. So that we have an x. And then we have an x minus 2 and an x minus 2. So x minus 2. This is our LCD. Now, we multiply everything times this LCD. So this is going to be x minus 2. What do we need to multiply this by to get this, right? Well, by the x. So the 2 needs to be multiplied by the x. So we're going to get 2x over, and this is going to cancel because it's going to cancel right there. So over nothing, okay? So that cancels. Same thing here. We're going to have x minus 2 over 1. This x cancels with this one, and so we end up with 2 times, and you can just go ahead and put that through, 2x minus 4. And the same thing here, only when we do this, the x minus 2, And so all that we're left with is, so this whole denominator cancels because this was the factor denominator. This whole thing cancels, and so we're just left with 4 times 1, so equals 4. Now we just kind of combine like terms. That combines right there, so we get 4x plus 4 and equals 8. Divide both sides by 4 to get x by itself, and we get x equals 2, and that would be our answer on that one. And again, I'm just going through these, and this is on page 349 if you want to look through your book while I'm doing these on the paper. All right, last one. Okay, last one. Same process. What is our LCD? LCD. Our LCD, well, we got to factor this one. So this one is the difference of 2 squares. And this one gives us x plus 3x minus 3, because that's a conjugate right there. And so remember, it's a little tricky right here, but remember, we take one of each. So there's an x plus 3, there's an x plus 3. So that's one of ours in our LCD is the x plus 3. The other one is an x minus 3 and an x minus 3, so we just need one of those, x minus 3. So those are our two LCDs. Those are our two things that we need in our denominators. So we take this and we multiply this times each one of these. Okay, so x plus 3, x minus 3, x plus 3, x minus 3 over 1 times this. And what happens here? X plus 3 cancels with x plus 3. And then we have this, x times x minus 3. We can go ahead and put that through to give us an x squared minus 3x. Same thing here, x plus 3, x minus 3 over 1, x minus 3, x minus 3, and we end up with the x plus 3. This is a plus, x plus 3. And then we would do the same thing here, the x plus 3, x minus 3. Notice that all of that cancels, and we're just left over with our 6. So kind of the same thing that happened last time happened again. All right, so now we want to combine these things. The x squared, we don't have anything to combine it with, so it just gets an x squared. And then here's a negative 3x and an x, and so that's going to give us a negative 2x. And then with this one, we'll take the 6 over here to the other side. Why am I doing that? Because we have an x squared, and we're going to need to factor this thing. So we're moving the negative 6, negative 6. This is going to give us a minus 3 equals 0, because this cancels out to 0. All right, so there we go. And now we need to try to factor this. How do we factor? Well, we factor by, giving an x and an x. And these are both going to equal 0 in this case. And so we have to just factor our negative 3. So 3 is, a 1 times 3. And our signs are going to be a positive and a negative. So a positive and a negative. And the bigger is going to go with the negative since this is negative. So we'll put negative 3 and a positive 1. That's our factors. And now we're going to move the 1 to the other side by subtracting 1 from each side and say that x equals negative 1. So there's one of our answers. And then here we're going to move the 3 over by adding 3 to both sides. X equals positive 3. So those would be our two answers there. Now there's one more thing that we need to do with this, and then I will let you go for this lesson. So turn back, look in your book. I'm not going to show you this on the screen. I'm just going to show you this in the book. On this second to last one here, the answer is actually no solution, and there's a reason, because we got x equals 2. So if you go back to my work, we had x equals 2. However, when you put x equals 2 into this, look what happens right here. X, if you put a 2 right here, 2 minus 2 equals 0. Anything that zeroes this out cannot be an answer. So even though we get 2 for an answer, When we plug it back in, we find out that 2 can't be an answer, because if x equals 2, then 2 actually makes this go to a math error, undefined. You can never have 0 in the denominator, so we would write no solution. Always check your answers. So when you check this one, it's called this over here, this word extraneous. Extraneous means it gives you a solution, but that solution does not check. Okay, in this one, the last one that we did, when we had x equals -1 and x equals 3, when we plug those in, when we plug 3 in here, notice that 3 minus 3 equals 0. 3 cannot be a solution, so the only one you would list is the -1. You would not list the 3, because 3 is extraneous. All right, so that's a little bit technical right there, and that's going to get more into Algebra 2 stuff, but I want you to see it so that you make sure, always remember to check these and find out, does this answer actually satisfy the original equation that we're given? If it does, circle it's part of the answer. If it doesn't, if it gives you denominator of 0, then X that out. It is not part of the solution. Well, that's all I've got for you. Hopefully you learned something there. If you missed anything, slide it back, watch it again. We'll see you later. Have a good one. Bye-bye.